In this video, we're going to take a look at and review what the AP curriculum calls Unit 6. Their Unit 6 is on normal arrays, so not array lists, just normal arrays. And some of the topics that we're going to take a look at in this unit are how to create an array and how to access individual cells within the array. We're going to look at something they call traversing an array, and what that basically means is going through all the different elements in the array, using the index as the control variable for some kind of a loop. We're going to take a look at a new kind of loop, something they call a for each loop. Actually, they have a different name for it, but that's what we learned it as. We called it a for each loop. And we're also going to look at some algorithms that solve problems using arrays. So the first thing that we need to know is that arrays allow the coder to represent multiple related items in one variable. So for example, if you have an account, a bank account class, and you decide you want to make 50 bank accounts, it would be helpful if we group them all together so we could actually make an array of 50 bank accounts. For normal arrays, the size is established at the time of instantiation and cannot be changed thereafter. So if you have made an array of 50 bank accounts, and you later decide I want to have 51 bank accounts, you can't just add on to your array. You'd actually have to create an entirely new array, copy the 50 that you have already in there into the new array, and then add the extra one on. You probably want to delete the old array so you don't have all this extra memory tied up. So it's kind of a pain in the butt to change the size of an array because you create a new array to do this. Arrays can store intrinsic types or user-defined types. So it can store integers, doubles, floats, booleans, but it can also store any kind of class that you've already written. So if we have a bank account class, we can make an array of bank accounts. When an array is created, you use the keyword new to ask for memory, and the array gets filled with default values. So the default value is going to be 0 for any of the numerical types like integer, doubles. The default value is going to be false if you're making an array of booleans. And the default value is going to be null if you're making an array of user-defined types. Now the only exception to this would be unless you specify at the time of instantiation the values that you want inside of curly braces. So let me show you two different ways to begin creating an array. Here's the first example. On the left-hand side, we're saying we're going to have an array with the square brackets that tells you there's going to be an array of integers. So, and that array of integers is going to be called X. That's the name of the array. On the right-hand side, we're asking for some new memory, and we're saying how many memory locations we want inside the square brackets. So what this line of code right here does is it creates a new array called X, which contains integer types and asks for 15 memory locations. And because we've not assigned any values to these memory locations, Java automatically fills in all 15 of those memory locations with zeros, because integer is a numerical type. Now, something else that you can do, something a little different, is when you're creating your array, int array y, instead of asking for new and declaring how many memory locations you want, you can actually put what you'd like to become the values the array stores inside of braces. So 3, 5, 7, 9, 11 tells Java, I need 5 memory locations. And so this is going to know how much memory to ask for. And then it automatically starts filling in those indices with the numerical values that it sees here instead of default values. So this creates an array with 5 memory locations, and the numbers inside of it are 3, 5, 7, 9, 11. Remember, indexing starts from 0. So the 3 is actually going to be at index 0. This would be index 1, 2, 3, and this would be index 4. Once you've created an array, you're going to use the square brackets to access individual elements within the array. For example, in the array that we just created, it was called y, we can go in and change the element that's at index 2 by saying y, square brackets with a 2 inside of it, and then assigning a new value. So whatever value used to be in this location is going to get replaced with the number 13. Now, one thing to be careful of with your arrays, of course, is you have to make sure the thing you're assigning into here matches the type that this array can store. So array Y was an integer type array, so we can only put integers into it. If you try to put a string into here or a bank account into here, this would not work, and you'd run into a class cast exception. The index numbers for any array range from 0 to the size of your array minus 1. And using an index number outside of that range will result in something called an array index out of bounds exception. So let's say we have an array of 50 bank accounts. If you try to access bank account at index -3, that's going to create an exception. Or if you tried to access a bank account at index 50 or anything above 50, that would also create an exception, because if you have 50 memory locations, your indexing would go from 0 to 49. The length properties of an array tells the total number of memory locations that you can access. So length is actually a public class variable for the array class. And so all you have to do is say the name of the array dot length. This is not a method, so there's no open and close parentheses on the end. Now, the tricky thing about this is when you do this, it's going to tell you the total number of memory locations. So if you have 50 bank accounts in an array and you do the array name dot length, you're going to get 50. But remember that indexing goes up to 1 less than that. So you have to make sure that your indexing stays less than the length. Iteration statements can be written to access all the elements in the array. This is called traversing an array. So traversing the array is oftentimes done with loops, and this requires calling each element of the array by its index. So for an example, and we've done this hundreds of times in this class, we could set up a for loop going from int j equals 0, j is less than y dot length, y is an array. The dot length property tells me how many memory locations I have. We'd want to stay less than that, because if you let it go bigger than or equal to the length, you're going to go outside of your indexing range. And then I'm going to increment by ones. So system.out.println y at the jth location is going to go through each and every index in the y array and print each one out. When traversing an array, be careful about the end indices. Okay, this is where people usually mess up. If they're going to mess up on the AP exam, oftentimes they either start too low or finish too high. And again, that's going to give you an array index out of bounds exception. Sometimes they'll actually specifically ask questions about what happens if I try this number in here, just to see if you know that that's the kind of exception that would get created. Java provides a special kind of loop that is specifically designed for traversing a normal array, and actually it can also traverse an array list. That's going to be our next unit. But we have to understand the way regular arrays work first. We called this in class a for each loop. Sometimes the AP curriculum refers to it as what they call an enhanced for loop. So we called it for each loops. They call it enhanced loop. And the way that this particular this loop works, you start the header by creating a variable that's the same type as your array. So for example, if you have an integer array that you'd like to process through, and you've got the numbers 2, 3, 4, 5, 6, 7, you would want your for loop to have an integer type variable here ready to pick out each one of these individual items that you're planning on pulling out. So int x is going to temporarily store each one of these values one at a time. If this was an array of bank accounts, then right here you'd want to have a bank account object waiting to receive each one of those things. Then there's going to be a colon, not a semicolon, a colon, and then the name of the array that you'd like to traverse. So since the name of my array here is numbers, that is the name of the array that I'm going to traverse. So what's going to happen then is it's going to start from index 0 and go through every single element in the numbers array, pulling them out one at a time and temporarily storing them as x. oftentimes they call this value right here the loop variable. So x is the loop variable. Now all I'm really doing here inside of this enhanced loop is I'm just printing out each value. So it's going to go and get the 2, it's going to store it as x, and then it's going to print it out. Then it's going to go and get the 3 and store it as x, and then print it out. Then it's going to go get the 4, store it as x, print it out. You understand the way this works. One of the things we will not have to worry about, so when we were doing this for each loop, oftentimes we had an array list that could store multiple different types of values, and we had to check to see what kind of variable it was. So we used instance of, and sometimes we had to do some typecasting. So they're not doing polymorphism this year, so we won't have to worry about such things this year. If you make a change to the loop variable inside the for each loop, it does not affect the value stored in the array. So basically, you're copying this value into x. So if for some reason, like inside of this for each loop right here, I said now x equals 17, that change does not stick in the numbers array. So it's passed by value, basically. You should also know write the same process using, you should know how to write the same process using a regular for loop or a regular while loop. So we should be able to take one of these enhanced loops and change the way it processes to do it with a different kind of a loop. So maybe using a for loop or a while loop. Or maybe taking a for loop or a while loop and writing it as one of these enhanced for loops, or what they call a for each loop. Okay, last thing that we want to talk about in regards to arrays, there are some specific tasks that you should be able to know how to set up a code to do while traversing an array. So for example, you should be able to go through an array and determine either a minimum or maximum value. So really quickly, if you were, for example, going to try to find a minimum value within an array, what I would do is I would make, for example, let's say it's an integer type array. I would set my initial minimum value equal to the first element in the array at index 0, and then I would systematically go through each and every value in the array to see if it's lower than my current minimum value. If it is, I would reset it equal to that number, and if not, I would keep processing through the array. You should know how to compute a sum or an average of all the values in the array. So this would require that you're setting up some kind of accumulation variable. I'd start it off at 0, and then we would go through and keep adding on the current value that's stored in the index to our accumulation variable. That would create your sum. And if you're wanting to do an average, do the sum and then divide by the number of elements that are in the array. You should be able to determine the presence or absence of duplicate elements. So for example, you'd want to start off by making your first element equal to the number you're searching for, and then go through the rest of the array to see if it happens again. And this would actually be a nested loop situation, because then, let's say that the first element was not duplicated, you then have to set the second element equal to your target value and search through the rest of the array for that, and so on and so forth. So this would actually be a loop inside of a loop. Determine the number of elements with certain criteria. So maybe we're looking for a match for some particular value, or something that's bigger than something or smaller than something. You might be asked to find the index of the first occurrence, or sometimes maybe they'll ask you for the last occurrence. So if they're asking you for the index of the first occurrence, you'd want to start from index 0 and go until you find a match. If they're asking you for the last occurrence, you'd probably want to start from the end of the array, which would be the index would be size minus 1, and work your way backwards through the array to find the element that you're looking for. They might want you to shift all of the values in the array to the right or to the left. So we might swap out values with their neighbor. Now, if they do that, the one thing that would be really tricky then to consider is the ends. If you're shifting everybody to the left one index, then that means index 0 is actually going to end up all the way at the end of the array. So just a few things to consider. Some things might not be done within the loop itself. You might have to do outside the loop. And lastly, they might ask you to reverse all the values in an array. So if your values in the array are increasing, like 1, 2, 3, 4, they might ask you to write that array in reverse order, 4, 3, 2, 1. So make an array with the same size, work through one of your arrays forward, and work through one of your arrays backwards, assigning values from one to the other. Well, with these concepts, you are now ready to try the problems in the Unit 6 personal challenge. I'm assigning part 1 today, which is multiple choice, and the free response in part 2 will be assigned tomorrow.